Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about mean of the system response and also determine power spectral density of the output. And this is the previous examination question. The example is x of t is a stationary random process with 0 and autocorrelation function Rxx of tau is 3 e power minus 2 mod tau is applied to a system function h of omega is 1 by j omega plus 2. Find the mean and power spectral density of its output. Coming to the solution, given that the autocorrelation function is Rxx of tau is equal 3 into e power minus 2 mod tau and frequency response of the system or the system function h of omega is equal 1 by 2 plus j omega. So we know that the Fourier transform of e power minus a mod t is 2a by a square plus omega square. Using this standard expression, so determine the Fourier transform of Rxx of tau value. So in the given autocorrelation function, taking the Fourier transform on both sides, Fourier transform of autocorrelation function is equal Fourier transform of 3 into e power minus 2 mod tau. So 3 is constant, that is written before Fourier transform. So we know that the Fourier transform of autocorrelation function is power spectral density of x of t, that is sxx of omega 3 into, so Fourier transform of e power minus 2 mod tau is 2a. Now here the a is 2a by a square plus omega square. Now here the a is 2 into 2 by 2 square plus omega square. Simple reducing the RHS term, 2 into 2, 4 into 3, 12. So the power spectral density of the random process x of t is sxx of omega is 12 by 4 plus omega square. So given that the frequency response of the system or the system function h of omega is equal 1 by 2 plus j omega. So calculate the taking magnitude on both sides. Magnitude of LHS term is equal to magnitude of RHS term. So numerator of this equation is 1. So magnitude of 1 is 1. Denominator of the magnitude of 2 plus j omega is, now here the real part is 2 and the imaginary part is omega. So the magnitude of 2 plus j omega is square root of 2 square plus omega square. So which is equal to magnitude of h of, now taking the square on both sides, magnitude of h of omega whole square is equal 1 by 4 plus omega square. So we know that the power spectral density of the output is Syy of omega is equal to magnitude of h of omega whole square into Sxx of omega. So now here Sxx of omega value is calculated and magnitude of h of omega value is calculated, and substitute those two values into this equation, we get the power spectral density of the output y of t. So now here magnitude of h of omega whole square is 1 by 4 plus omega square into Sxx of omega is 12 by 4 plus omega square. The power spectral density of the output y of t is Syy of omega is equal to 12 by 4 plus omega square whole square. Next, find out the expected value of the output, mean of the output y of t. So given that the mean of the input is 0. So mean of the input is 0 mean expectation of the random signal, random process x of t is 0. That is expectation of x of t is equal to 0. So we know that the mean of the output y of t is expectation of y of t is equal to h of 0 into expectation of x of t. So now here from the given data, expectation of x of t is equal to 0. Substitute that value into this equation, we get the mean of the output y of t is 0.